Hello, Precalculus students, to day 2 of this lesson on being able to convert points from polar to rectangular or vice versa. In the previous lesson, we talked about how to convert a point that is written already in polar coordinates to rectangular coordinates. And the two main formulas that we got as a result of that little investigation were x is equal to r times cosine of theta and y is equal to r times sine of theta. So now we're going to do the reverse. Now let's assume Now let's assume we have a point written in rectangular coordinates and we have to convert that to polar coordinates. So I'm using the same diagram as the previous lesson, except this time let's pretend we know what x is and what y is. So we know these two sides of this right triangle, and we have to figure out what r and theta are respectively. So first, let's try to determine what r is equal to. Well, let's see. We have a right triangle. And we know two sides of this right triangle. So hopefully, this is one of the very early formulas that you ever learned. We're going to use the Pythagorean theorem. So we got our x squared plus our y squared is equal to r squared. Now to solve for r, we got to get rid of that squared. So we're going to take square root of both sides, So we end up with r is equal to the square root of x squared plus y squared. So that is our formula that we use to solve for r. Simple Pythagorean theorem. Not much else to it. So now let's think about theta. Now theta, there's more than one way to think about it, but the main way you want to think about it is, all right, we just know x, we just know y. Let's pretend we don't know r, even though we could have just solved for r at this point. So we know two sides of this triangle. We're trying to find this angle inside. Well, we want to use some trig, right? So we have two sides of a triangle. We want to find one of the angles of a right triangle. Well, this is our adjacent side. This is our opposite side. So think about this. What trig function involves just the opposite and adjacent side? Take a few seconds to think about it. Hopefully you thought about tangent. So we're going to be using tangent for this one. So tangent of theta is equal to y, opposite, over adjacent x. Now to solve for theta, if you recall, in order to get rid of a tangent, you have to do tan inverse of both sides. So we're going to do tan inverse of that side and tan inverse of that side. So tan inverse of tangent of theta and tan inverse of y over x. And the reason why we do that is that these two cancel out. So now we're just left with theta is equal to whatever tan inverse of y over x is. Now, the only thing you want to be careful of, and you'll see in the examples that we do, the only thing you want to be careful of is that this answer, the answer that's going to result from plugging this into a calculator will not always be appropriate to the quadrant in which you're in. So you do want to make sure that the angle that you get is in the appropriate quadrant. So if your point is, in the first quadrant, your answer should be between 0 and 90 degrees. If it's in the second quadrant, your answer should be between 90 and 180, and so on and so forth. Excuse me. So let's try a few examples using these formulas. So this next slide is just basically an overview of the formulas that we found. So x is equal to r cosine theta, y is equal to r sine theta, tangent of theta is equal to y over x, x squared plus y squared is equal to r squared. So those are the main formulas that we're going to be using. So once again, today we're going to be focusing on, this is what we did in our previous lesson. Today we're going to be focusing on these points are already x comma y, and we're trying to find r and theta. So r and theta. So let's do that. So we said that x squared plus y squared is equal to r squared. So 4 squared plus negative 4 squared is equal to r squared. So 16 plus negative 4 squared is still positive 16 r squared. So r squared is equal to 32. So r is equal to the square root of 32. So that's our r value. Now let's do theta. So tangent of theta is equal to y over x, which in this case is negative 4 over 4, which is negative 1. Now, for this problem, let's try to think about the unit circle. All right, let's try to think about the unit circle. So let's not use a calculator. Let's try to think of the unit circle. So where on the unit circle would tangent be equal to negative 1? Where on the unit circle would tangent be equal to negative 1? Actually, let me see if I can pull up a unit circle really quickly. All right. So unit circle. There we go. All right, so let's look at our unit circle here. So where in this unit circle would tangent be equal to negative 1? So right off the bat, the only values you should be focusing on are these pi over 4. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now the reason why is, think about it. Since tangent is equal to y over x, we want both the y and x values to be the same, because when we divide them, we want 1, right? When you divide the same value by... when you divide a number by itself, you get 1. So either we're looking at pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Well, let's see. Pi over 4, those are both positive numbers. So if you divide them, you get positive 1. So we don't want that. 3 pi over 4, one of them is negative, one of them is positive. So if you divide those, both of them are, you get a negative answer, so that might work. 5 pi over 4 won't work because since both of them are negative, if you divide a negative number by a negative number, you get a positive. 7 pi over 4 will work since they have opposite signs. Now the question is, which one is it? Is it 3 pi over 4 or is it 7 pi over 4? Well, remember, I told you before, it's determined by which quadrant this is going to be in. So think about it. 4 comma negative 4. So 4 tells us to go right 4. Negative 4 tells us to go down 4. So what quadrant is that in? Well, if I quickly do a little diagram here. So to the right 4, down 4. So it looks like we're going to be in quadrant 4. And of those two answers, 7 pi over 4 is in quadrant 4. So that is the answer we're going to be using, 7 pi over 4. Or 315 if you want to write it in angle as an angle measure. So theta is equal to 7 pi over 4 or 315 degrees. So that means our final answer here is square root of 32. Comma 7 pi over 4. Well, there you go. So let's do the same thing in B. So let's see what we got here. So we have negative 2 squared plus 2 square root of 3 squared is equal to r squared. So negative 2 squared is 4. 2 radical 3 squared, is 4 times 3, so that's 12. So that's r squared. So it looks like 16 is equal to r squared. So r is equal to 4. So r is equal to 4. Let's find theta now. So tangent of theta is equal to y over x. 2's cancel out. The negative still stays there though. So negative radical 3. Sorry about that. Negative radical 3. All right. So this one's going to be a little bit trickier. So we want the square root of 3 to be on top. If you notice, we want the square root of 3 to be on top. All right. Sorry about that. So now if you look at our unit circles here. So let's see. So remember, tangent is y over x. Y over x. Well, let's see. Pi over 6, we get 1 over 2 over radical 3 over 2. But we want the square root of 3 to be on top. So it's not going to be that one. Pi over 3, we get square root of 3 over 2 over 1/2. That could work. Square root of 3 is on top. But we want negative, so that's not going to work. 2 pi over 3, that could work. Get the negative over there, and the square root of 3 is on top. 5 pi over 6 won't work. 4 pi over 3 will work, since the square root of 3 is going to be on top, right? Because that's the y value. But both of them are negative. So if you divide two numbers that are both negative, it gives you a positive number, so that won't work. So it looks like our two choices are 2 pi over 3 or 5 pi over 3. Now, which one of them is it? Well, let's look at the quadrant again. Our x value is negative. Our y value is positive. So that means we would be going to the left and up. So that means our point would be in quadrant 3. Quadrant 3. So it looks like our answer is 2 pi over 3. 2 pi over 3, because that's our, wait, did I say quadrant 3? I meant quadrant 2. Since our y value would be in the numerator, which is what we want it. We want it to be in the numerator, as we saw in this problem. It's in the numerator here. All right. So it looks like our answer is 2 pi over 3, or if you put it as an angle measure, 120 degrees. So our final answer is 4, 120 degrees, or 2 pi over 3. And then finally, let's do this last one. So we have, negative 6 squared plus negative 1 squared is equal to r squared. So we have 36 plus 1 is equal to r squared. So 37 is equal to r squared. So r is equal to the square root of 37. Now let's figure out what theta is equal to. Theta is equal to, so tangent of theta is equal to negative 1 over negative 6. Negatives cancel out, 1 over 6. Now for this one, hopefully, if you look at your unit circle, there is not a 6 to be seen, nowhere to be seen in any of these coordinate values. Hence, tangent, at least on the unit circle, is not going to equal any of these more convenient values. So this is a problem in which you would use a calculator. So we would use the tangent inverse this time. So theta is equal to the tangent inverse of 1 over 6. And you should get, let's see. So tangent inverse, let's do that. So trig, tangent inverse of 1 divided by 6. Make sure you're in degrees mode, probably would be best. So you get 9.46 degrees. 9.46 degrees. So 9.46 degrees. But there's a problem. This 9.46 degrees is not in the correct quadrant. How do I know? Well, think about it. Negative 6 comma negative 1. If you were to graph that, that means you would be going left 6 down 1. So left 6 down 1, that's in quadrant 3. Our angle is in quadrant 1. So how do we make sure it's in the correct quadrant? Well, we're in quadrant 1, so to get to quadrant 3, we just got to add 180. So we just got to add 180 to make sure it's in quadrant 3. So quadrant 3, we're going to add 180 to this. So we get 189.46 degrees. 189.46 degrees. So our final answer for this problem is the square root of 37, 189.46 degrees. So that's our final answer for that one. So once again, you always want to make sure your angle's in the correct quadrant. If it's not in the correct quadrant, means you got to add something. You got to look somewhere else on your unit circle to make sure you get the correct point. So that is how you convert a point that is given in rectangular to polar. So as you can see, it shouldn't be, it should be just, if not as easy as yesterday's lesson or the previous day's lesson, maybe a little bit harder. But otherwise, as you can see, it's not too much. In terms of assignment, your next assignment will be another extra practice handout that I will be posting. It will be due the next time that we meet. It will be extra credit again. It's just like the previous handout that you completed, so it's just more problems like this, but this time converting from rectangular to polar. Otherwise, I hope you guys are staying safe, and I hope you enjoy. Oh, actually, one last thing. Actually, no, that's about it. I hope you guys enjoy the rest of your day, and I will see you later.